Today we're going to talk about Newton's three laws of motion and how they pertain to a particular activity. So let's begin by looking at a video from Period 3 Physics. To explain what happens here, I set up a tug-of-war between the boys on the left and the girls on the right. The only trick being that the boys were not allowed to wear shoes and the girls were. And we'll see what effect that has. So first we'll watch the clip and then we'll discuss what physics is. Alright, so let's see which of Newton's laws were illustrated here. Newton's first law is, of course, the law of inertia, which states that any object in motion will stay in motion, and any object at rest will stay at rest unless acted upon by an outside force. Alright, well, when the tug-of-war started, the people involved, were at rest. And of course they will stay at rest unless acted upon by some outside force. And that was quite obviously the force that caused them to move was provided by the other team. And then they were an object in motion. Newton's second law is the formula version, which says F equals ma, or that a force is required to accelerate an object and change its motion. If you watch towards the end of that clip, you can actually see as the boys begin to lose, they actually begin to accelerate down the hallway. But the clip is probably best exemplified by Newton's third law. For every action there is an equal and opposite reaction. It turns out if you pull on the rope pulls back on you. If you pull with 100 pounds of force on the rope pulls back on you with 100 pounds of force. So pulling on the rope actually doesn't make any difference. So what makes the difference? Why did I have the girls wear their shoes and the boys take them off? Friction. Right? It's not about how hard you pull on the rope, because if you pull on the rope pulls right back on you with the same amount of force, and that really doesn't accomplish anything. Much more important is the interaction between your foot and the ground. Because if you can push off the ground can then push back off of you. And therefore, as long as that force is more significant than the force created by the pulling ropes, then you can win the tug-of-war. Trying to win a tug-of-war is not about how hard you pull on the rope. Instead, it's about how hard you can push off the ground. We will watch the video one more time, and I'd like you to notice, in particular, the student at the head of the boys' line, who seems so unconcerned about losing to the girls until it begins to happen.